Ottawa has a really interesting and varied geologic history, and in this project, you're going to learn all about it. First, I'm going to give you an overview of the region's geologic history, highlighting some of the major events. Then, we're going to go on a virtual field trip around the region where you'll get to see evidence of these events. You'll write a report on the field trip and tell me how these field trip locations tie into the geologic history of the region. Then, eventually, you'll go on your own actual field trip and tell me how that location fits into Ottawa's geologic history. So, as you know, the Earth is about 4.6 billion years old. The oldest rocks in our region are much younger than that, but still very old. They're from the Precambrian, about 1.2 to 1 billion years old. These rocks that make up the Gatineau Hills, like you see off in the distance behind me, they also make up the hills near Calabogie and Pakenham. Those two locations you might recognize because they're popular ski hills. And they can also be found exposed in some parts of Carp and Canada. These Precambrian rocks are actually all that's left behind from really old mountains that were once as tall as the Himalayas are today. These ancient mountains formed along the margin of ancient North America. They started out as sedimentary and sometimes igneous rocks, but they were deformed and metamorphosed and then cross-cut by magma when they collided with another continent. What's left behind is mostly metamorphic rock, gneiss, quartzite, and sometimes marble. The mountain building process stopped about 1 billion years ago, and since then the mountains have just kept eroding down. All that's left behind are the hills like the ones you see behind me. The next major geologic event that happened in Ottawa's history was in the Paleozoic era. In the Cambrian period, about 510 million years ago, a warm tropical sea flooded the region. Present-day Ottawa was a lot closer to the equator then. The region was actually a tropical beach, and the sand that was deposited then has undergone lithification and is now a layer of sandstone known as the Nepean sandstone. It's actually the same rock that was used to build the Parliament buildings. About 70 million years later, in the Ordovician, a deeper ocean covered this beach and limestones and shales were deposited. You'll still find fossils of organisms that lived in that ocean in the limestones and shales around Ottawa. Sometimes trilobites, sometimes tiny little things that look like seashells. They're good evidence that we were once underneath an ocean. Then, about 175 million years ago, in the Mesozoic era, the Jurassic period, there was some serious tectonic action here. A rift valley formed where the Ottawa River runs today. This means that there were two fault lines on either side of the valley, and the valley fell below. Hopefully, you remember that this kind of faulting results in what's called a graben. The graben, where the Ottawa River runs today, and where I'm standing right now, is called the Ottawa Bonshare Graben. It dropped below the hills on either side, so it fell below what's now the Gatineau Hills. And today, the Gatineau Hills on the one side of the graben are about 340 meters higher in elevation than the Ottawa River Valley. And the hills near Calabogie on the other side of the graben are about 310 meters higher than the valley floor. And even though this is a failed rift valley, you can still sometimes feel the effects of those fault lines here. We do still have minor earthquakes here in Ottawa. Much more recently, in the Quaternary period, the entire planet was affected by an ice age, and our region was under a huge ice sheet. The ice sheet advanced and retreated several times in the last 1.6 million years, but the most recent glaciation happened from 20,000 to 11,000 years ago. There's a lot of evidence of the glaciation in this region. You can see some places where there are scrapes on the bedrock called striations, or places where the bedrock has been completely polished smooth by the glaciers. You'll see some places where the glaciers deposited large boulders that were tens or hundreds of kilometers away from where they originated. And then much of the sand and the gravel that's left behind in the region was deposited by these glaciers as well. As the glaciers retreated about 11,000 years ago, it took a while for the land to rebound, literally bounce back from the weight of the ice that sat on top of it. The land was so much lower that the Atlantic Ocean actually flooded up the St. Lawrence and up the Ottawa River and covered the entire region in what is called the Champlain Sea. This sea left behind a layer of clay in many parts of the region called the Leda clay, and it's been pretty problematic as it's prone to landslides. Also, interestingly, and more on a biology note than a geology one, there were some saltwater fish that were left behind when the Champlain Sea retreated. If you ever make it up to Pink Lake in Gatineau Park, there are some salmon-type fish that were once saltwater but have evolved to live in freshwater, and they can now still be found in Pink Lake. Lastly, even now, our region is still changing. The Ottawa River is a good example. Sediment from upstream gets deposited where the river slows down, and over the centuries, the river will change its course a bit.